What is going on, guys? Welcome back to another video. So today I want to show you how to make tissue culture media for beginners. So originally this video was for a client. However, I also wanted to post it here on YouTube, as it's been a long time since I have posted a video on how to make tissue culture media, especially since in the last few months we have seen, I have seen a lot of interest on new people that they don't know what tissue culture is or how tissue culture works, and they want to learn how to make tissue culture. So obviously the first step is on making medium. So this is a little bit of a longer video. It is a more detailed, hopefully explains better of what tissue or how to make tissue culture media. Obviously, you have any questions, leave it down in the comments, and then I will try to discuss on another video. So without further ado, let's go into the video. All right, so get ready. It's going to be quite a long video, as I want to show you step by step on how to make tissue culture media. I want to try to go as slow as possible, so hopefully you can get as much information as possible. If not, use send me a message and you can ask me any questions. So let me show you the materials I've been using. So start off measuring cup, and I have a magnetic stirrer because I like to use a magnetic stirrer. You don't have to, you can just use a spoon, but having one of these when you do tissue culture frequently, it really helps. So let me plug this up. So this goes here. This goes here. Second, you need water. You need the still water. This is water from a reverse osmosis filter, so it works fine, but you can just go to the grocery store and get the still water. Make sure it's the still water, not the spring water that still has some solids in the water. So let's start by, I want to make 1 liter of media. The amount of media you want to use, it depends of, like, I want to use the biocoupler, which it is, what is it? It is 16 ounces, which if we do to kind of the metric system, it is about 480 or so milliliters. So I'm going to do 400 milliliters for the biocoupler. I'm going to do 1 liter of media. The rest of the media I'm going to be using for some other normal traditional tissue culture other than the biocoupler. So to start off, let's start with adding the water into my measuring cup. There we go. Now I added 950 milliliters. I want to do 1000, but I only added 950, and the reason is because whenever I add the sugar, which is right here, this is just table sugar, the one you can get from your grocery store. You probably already have some of this. It's going to add volume and it's going to change my ratio. So I have my next, I have my scale. This is about like a $10 scale from Amazon. It's very cheap, very inexpensive. What I do like about this scale is that it has two measuring, it has two digital places. So it is fairly accurate for being that cheap. So I grab just one of daily containers, placing here. And I like to measure my sugar first, and the reason is because it takes the longest to dissolve. So I want to make a custom media for your philodendrons. So I want to use 30 grams of sugar. So let's measure 30 grams. $27, $28, $30. It doesn't have to be completely perfect. You just want to get it close enough. If you want to really, really be perfect, you can use a spoon. So this is good enough. Let's start spinning this media. Now it's going to get noisy. going to be noisy until it dissolves. So there we go. That's the sugar. That's going to be dissolving. Let's put this out of the way. Now I'm going to be using my MS media. This is the MS media we use here at Plant Farm Technology. It has all the nutrients, all the vitamins that the plants need, except for plant growth regulators, which I'm going to add here in a moment. So I'm going to make a full amount of MS, which is 4.5, is it 6 or okay. It is here is the instructions. Dissolve 4.54 grams of this MS media in 1000 milliliters of water. So that is the full stream MS media. For some of my plants, I dilute this amount to about half or 1/3 or 1/4, depending on the plants. For the philodendrons, I think full MS is going to do the best. But for example, for my carnivorous plants, I had to do 1/3. So I just take the 4.54 divided by 3, and that's the amount I use in 1 liter of water. So let me open this up. And then for this, I do need a spoon. All right. All right, for this, I do need a spoon. Want to be a little bit more accurate with this. Let's measure 4.54 grams. That's too much. 465, 427, 4.4, 43, 64, 58, 57, 51, 54. Perfect, that's perfect. So I don't need this anymore. Can go away. I just try to keep everything clean. I'm organizing here. So let's put this back. Let's put in the media. It's going to make a lot of chunks in the media, so it's going to take some time to dissolve as well. But if you're using a spoon, make sure to just keep going until it fully dissolves. But right, next, I want to add all my antibiotics, all my plant growth regulators, and the ppm. So let me grab everything. So I have a ppm. I have an AA, which is an auxin. This helps for root development. Now I'm making you multiplication media, but I also need to add rooting hormones. You have to have a balance. You have use a cytokinin, which is what is used for multiplication. But if you don't have an auxin, it just doesn't work. And don't ask me why, because I'm actually not sure why, but it just doesn't work that well. So now I have a 6BA. It's BA. So I'm going to also be adding this. And now for adding all of this into the media, when talking about plant growth regulators, you have to be really exact. This is where you really want to be as exact as possible. So you want to use either a syringe, a 1 milliliter syringe, or use a micropipette, like the one I have here. So this is a micropipette. This micropipette costs like $400. There are some cheaper ones, and on Amazon you can get a set for less than $100 where it has 3 of these micropipettes. Honestly, I only use the 1000 micropipette. I rarely use the other 2, which are 100 micros, which is 1/10 of a milliliter. This is 1 milliliter. The 100 micros is 1/10 of a milliliter. And then the 10 micros, which is, 1000 micros is 1 milliliter. So this one is a 10.
which is very small. That one is mostly used for more um, exact measurements, like some microbiology and stuff like that. But in tissue culture, plant tissue culture, we rarely use those micropipettes. Um, these are my micropipette tips. I use They are disposable, so you don't want to do any cross contamination. So as soon as I use it, I'm done with it, goes to the trash. Okay, so let me see. I use this. All right. So this is pretty much a dissolvent now. Let me just give it a little. Let's start with the ppm. The ppm is how we call it? It's a biocide. It is basically a fungicide and a bactericide, so it prevents the growth of fungus and bacteria. This is our main product here at Plant Cell Technology. Is widely known use on the tissue culture community, along not only hobbyists but also in professional level labs. So this is kind of our main product from Plant Cell Technology, and I want to be adding. Now you are a beginner, so I want to be adding 2 milliliters per liter. For myself, I only use 1 milliliter or half a milliliter. But for you, as is your pretty much your first time doing this, the tissue culture, um, I want to be adding 2 milliliters per liter, so trying to prevent as much of that contamination. The growth of the plant may slow down a little bit. However, you have a trade-off where the plant may not grow as fast, but contamination is going to be lower. Like hopefully you don't see any contamination. If you see any contamination, it's probably you probably need to work on having things clean, having everything as clean as possible. But I want to be adding 2 milliliters per liter. Hopefully that works for you. So I grab my micropipette with my micropipette tip, and I'm going to slowly add 2 milliliters. There we go. So I'm done with this. The tip, do not reuse them. It goes directly into the trash. There we go. Then close this. This goes back into the fridge. I'll do that in a second. Next, I want to add your cytokinin. In this case, I want to be using a BAP. I also want to be using a 1 milliliter. I want to be using 1 milliliter per liter. For philodendrons, it is recommended to do about 1 milliliter to 3 milliliters per liter. Your plants are very young, and they are just coming from out of tissue culture, and they're still very young. They are very fragile. They are very sensitive. So I rather start with a lower dose of cytokinin. You may don't have as much propagation as you may hoping. However, if I add more cytokinin, it may affect the growth of the plants more. It may not do. It may do more bad than good. I don't know if that makes sense. I was trying to right now at this stage, the goal is to get the plant established in tissue culture. As long as the plant is established in tissue culture, there is no contamination, you are good. Then after that, then you can increase the amount of cytokinins or amount of plant growth regulators, which I will send you some of these as well. So let me open this, grab my micropipette again. I grab another new tip. Make sure it's on 100, which is essentially 1000 or 1 milliliter. So I'm adding 1 milliliter per liter. 4 liter. I don't know why I always say per liter. I always say it in Spanish. I don't know why. Okay, this is done in the trash. Okay, so I'm done with my cytokinin. Now my auxin. For my auxin, I'm going to be adding 0.3 milliliters per liter. Now, you're asking why your cytokinin is much lower concentration than your auxin. Basically, you have a scale. When you do a multiplication, you want your cytokinin to be higher. You want your auxin to be lower. When you doing routing, you do the opposite. So I would do 1 milliliter per liter of NAA high, and then I would do the 0.3 milliliters per liter of BA. So use lower. So you change the concentration. Now, if you want to do, for some reason, want to grow callus, which you probably don't want to, when we're working on on the labs where we want to actually work with these plants, transform it into some genetically modification, then we want to do callus. And then what we do is that we use the same amount of auxin and the same amount of cytokinin. That's not always the case. Some plants do require certain auxins or certain cytokinins. Now we're talking about 2,4-D, IAA, some other different types of plant growth regulators. This is a little bit more advanced. You don't have to worry about any of this stuff at the moment. So 0.3 milliliters per liter. I have to adjust my micro pipette. So right now it's 100, and I had to go down to 30, which that is equivalent to 300 micros or 0.3 milliliters. So open the bottle, grab a new pipette tip. Now the hormones or the plant growth regulators that I'm using at the moment are heat stable. That means that I can add them before I sterilize my media. And I like to use heat stable plant growth regulators, especially also for beginners, as what will happen is if you use a non-heat stable plant growth regulators, you have to add them after the media has been sterilized and cool down. So you will wait. Basically, let's say that you make your media in a jar like this. So you have to wait until the media is still on liquid form because it has the agar or it has any other gelling agent. So you have to make sure to do it before it solidifies. It's still going to be hot, but it's going to be cool enough to add your plant growth regulators. Now those plant growth regulators, you have to add them using a syringe and a filter. So that is a little bit more complicated. I don't like to do it with them. I have done it in the past, but I don't like them. Whenever I can use synthetic plant growth regulators that are heat stable, I use them because I like them. They are easy, and I think this is much better for a beginner. So I'm done adding everything to my media. The only thing I have left to do before adding the gelling agent, although I'm not going to add the gelling agent yet because this need a liquid media. But before I do that, I need to calibrate the pH. So to calibrate the pH, I use sodium hydroxide to increase the pH. Basically, what is going to happen, I can put it in here. Tissue culture media is very acidic. Also, the water is very acidic. So the media is going to be, right now it's at 5.1, it's at 5, 4.9. It's going to keep going down a little bit more. You have to increase the media to between 5.4 and 5.8. I like to stay in the middle around 5.6. Right now it's at 4.7, 4.8. It's moving around those areas. So I need to increase the pH. To increase the pH, I use sodium hydroxide. However, you probably don't have sodium hydroxide laying around. You actually had to make the media around. There are some little pellets that you had to make your own. But you probably don't have any of these. So what you can do is instead of using this, use some baking powder, some baking soda, it works the same way. You need very little amount to add into the media. So you use a tiny little spoon and just add a few grains until the pH goes to between 5.4 and 5.8. Now, if you add it too much and it goes higher than that, you can use white distilled vinegar to decrease the pH and get it back down to that amount of 5.4 to 5.8. So let me add, let me grab a new tip. Oh, okay. Let me grab a new tip. Let me grab some of this. It doesn't take that much, it only takes a few drops. So I'm at 4.7, 4.8. It's probably going to take a little bit more than I thought. 4.5, 4.6, 5.7, 5.8. Okay, 5.7. That's pretty good. I'm actually pretty happy with that. 5.7. I'm pretty happy with that. So I'm going to leave it there. I just holding this for a few seconds more because I may take some time to stabilize. All right, so 5.7, 5.8. I'm very happy with that. Let's turn this off. Let's just shake it around a little. Let's put this on the side for now. This one, trash. There it goes. So, media is ready. Your media is ready. So, like I said, before I add the gelling agent, that's going to be media for myself. I'm going to take this jar. I already cleaned it. And where is it? Oh, here it is. Take this jar. And I want to take the media and pour it in here. About 3/4 of the way. About that much. Maybe just a little bit more. Now, something I did forget to mention is that I added 950 milliliters of water. I didn't have to add more, so I kind of forgot to mention. But that was because the sugar and the MS, they added a little bit of volume, and it got me to 1,000 milliliters. However, you need to make sure to check and add it if needed. But this is your media. It's done. So what I'm going to do is I'm going to close it on this jar. And I'm going to sterilize it. Now I'm going to, whenever you sterilize flask, it can be any flask, deli containers, any tissue culture container, make sure the lid is loose. If you have it completely, if the lid is tight, it can explode. So make sure it's loose. Now, let me give you a little tip. Whenever I do my biocouplers, like if I do it by myself, this is how I sterilize my biocouplers. I just take the whole thing and I put it into my pressure cooker, like I show you here. So here is my pressure cooker, and I put it in here. It fits perfectly for the height. However, if your pressure cooker is smaller, which I hope you have a pressure cooker because that's the best way to sterilize media. If your pressure cooker is not tall enough, what you will have to do, this is whenever using your biocoupler, is to sterilize the liquid by itself with the lid, Now you don't have a list like this because we didn't include it in the kit. You can find this very cheaply on the grocery store. You probably may already have some of these lists laying around. But you sterilize this by itself, and then the other part of the biocoupler, which is this is the top part. This is where the plants are going to be. This is where the plants are going to grow. You cover them with use some foil, some aluminum foil, and then this you place this in your pressure cooker, and then you sterilize them for 20 minutes. Whenever you now for the pressure cooker, please use a non-electric pressure cooker, unless you use the Instant Pot Max. Any other pressure cookers don't reach 15 psi, which is what you need to have to kill all these contaminants. You need 121 psi. I'm sorry, you need a 121 Celsius, or which is equivalent to 15 psi constant for 20 minutes. The electric pressure cookers, unfortunately, don't reach that. They may reach the 15 psi, but they don't stay at a constant 15 psi. They drop to around 11 to 13. So they are not the best. You can extend the period and it may work, but it's not 100% safe. So this is done. This is going into the pressure cooker. All I have to do is sterilize it. That's pretty much all I have to do left. The only thing I have to do left is use the rest of the media. Now for the 600 milliliters that I have left, I'm going to add my I want to add my gelling agent. This is gelling gum. So for gelling gum, I'm going to be adding about, it takes about 2 to 3 grams per liter. So I have 600 milliliters. So I just want to do about 1 to 1.5, and that'll be good enough to get a good gelling consistency. That was too much. There we go. 1.35. That's good. All right. So this is going to be media that I'm going to use for myself for my aquatic plants. Don't worry. I will send you some of these materials to make your own media. I'm going to send you just enough to get you going. So that's done. I just have to wait until it dissolves. Let me put this to the side. I have 600, so that's going to take me like, let's do like 8 or so. So I use one of these dispenser. I don't know how they call. I like this to place my media, to pour my media. Okay, so I have my media, and I'm going to place my lids. I really like using deli containers for tissue culture. We do have glass jars and reusable jars. However, I'm a really busy person. I absolutely hate doing dishes. I don't like to clean them. They're also kind of nasty, especially when they get contaminated. So having a disposable container like this really helps me out. It saves me a lot of time. Yes, I do waste a lot of, it's just a lot of plastic that goes into the waste. This is going to be sterile. Make sure to have like a clean box. Spray all over with ethanol or isopropyl alcohol. Spray everything all over. Spray your hands. Wear a mask so you don't breathe into your clean environment. And also, so you have two jars already. What I think the easiest way to move the plants is that only use one jar, sterilize the other part of the jar like this. You keep the other part with the you have the plant on the other jar with a lid and make sure it's clean. Sterilize the other part, and whenever you moving the plant, which hopefully already be sterile, but then you take the plant from the other jar. You want to open this very carefully. So you want to open it. You want to spray the jar with alcohol. Grab some sterile forceps. If you don't have a sterilizer like this or like an alcohol lamp, if you only moving that plant into the jar, to the biocoupler, you can just grab some aluminum foil, put your forceps on here, and then place it on the oven around 400 degrees for I don't know, maybe like 15 minutes or so, and that's going to sterilize your forceps. But also, you have a flame, you can flame it as well. Spray with alcohol and flame it. So you want to, let's say you have your other jar with the plant. You want to spray your hands as well. Make sure they are clean and sterile. You can wear gloves as well. I don't have gloves with me right now. You go to open this, and you want to open the other jar. Grab the plant, and as fast as you can, put it into this other jar and close it. Then you're going to take your other jar, take all your foil, and again, very quickly, as quick as you can, take it out and put the other one. And then you already have your jar in here, and then all you have to do is tape it, and then you just move it around. Okay, and that's pretty much all you want to do. Hopefully you have with this video has been enough material for you to move the plants by yourself. If you have any other questions, just let me know. It is difficult to make videos without having all the materials or all the plants around me, so it's a lot easier for me to actually doing it and explain it. But that's pretty much everything. I hope this has helped you, and let's see how it goes. Wish you luck. I think it's going to do well. Like I explained you already, I want you to start with one plant, as obviously there is a risk that you may kill the plant or contamination. If it is contamination, you can still save the plant, but keep in mind that the plant is very sensitive. It just came out of tissue culture, so it's very fragile, and it can potentially die from the sterilization process. So hopefully that doesn't happen, but that's why I told you to only use one plant, and make sure to keep the other plants, try to root the other plants, and then whenever they are stronger, then you can use those plants to experiment and try to introduce those plants if the first plant didn't work. So that's pretty much everything. I hope this helps, and if you have any questions, just let me know. Bye.